The first video we're going to make is for the problem Atlas INC that we discussed in class last week. In this problem, there are 5 workers working 7 tasks. The first question in this problem is, what is the bottleneck in this process? That is, which worker is the bottleneck in this process? The second question asks, what is the capacity of the assembly line, or what is the process capacity expressed as units per hour? Let's do these 2 problems first. Well, because there are 5 workers, we're going to make 5 rectangles to represent the 5 workers. 4 and 5th. So this is worker 1, this is worker 2, this is worker 3, 4 and 5. We have been given the processing times for each unit for each worker. Processing times, and the units is given as seconds per unit per bicycle. The first worker works 50 seconds on each bike. The second worker works 60 seconds per bike. The third worker works 30 seconds per bike. Fourth worker works 45 seconds, and the fifth worker works 40 seconds. Using the processing time, we can calculate the capacity. The formula for the capacity for each worker is M divided by the processing time, where M divided by processing time, where M is the number of worker in that station. Given that there is 1 worker in each station, the capacity is just 1 divided by 50. Now the unit here is units per second because the processing time is expressed as seconds per unit. The value here is 1 by 60, 1 by 30, 1 by 45 and 1 by 40. But remember, in this problem, in the second part of this problem, it asks us to find the process capacity in units per hour. One way to do this problem is express all the capacities in units per hour. Let's go and calculate capacity in terms of units per minute first. We have capacity expressed as units per second, and we want to go to units per minute. How do we get there? So we have second at the bottom, but here we want to reach minute at the bottom. So we have to get rid of this seconds. To get rid of seconds, we need seconds on the top, and to introduce minute at the bottom, we need minute at the bottom. But we have to make the top and bottom equal. The only way we can do that is 60 seconds is same as 1 minute. Thus, we can get rid of this second and this second. So we know that to go from units per second to units per minute, we have to multiply by this value, 60 divided by 1, which is same as 60. So we can go from units per second to units per minute by multiplying the value by 60, which is same as 1.2. 1 by 60 multiplied by 60 is 1. 1 by 30 multiplied by 60 is 2. 1 by 45 multiplied by 60 is 1.333. 1 by 40 multiplied by 60 is 1.5. Our job is not done yet. We want to calculate the capacity expressed as units per hour. To go from units per minute to units per hour, again we can do the same exercise. We have units per minute and we want to reach to units per hour. We have minutes at the bottom and we want to get rid of minutes. So we have to introduce minutes on the top. We want to introduce hour, so we need hour at the bottom. The only way to make this equal, the top and bottom equal, is 60 minutes is same as 1 hour. We can get rid of minutes now. Thus we get units per hour. So we know that to go from units per minute to units per hour, we have to multiply by 60 divided by 1, which is same as saying multiplying by 60. Okay, so we have capacity expressed as units per minute. So we have 1.2 multiplied by 60 equals to 72. 1 multiplied by 60 is 60. 2 multiplied by 60 is 120. 1.333 multiplied by 60 is 80. 1.5 multiplied by 60 is 90. So we have calculated the capacity of each step in 3 units, in units per second, units per minute, and units per hour. To find the bottleneck of the process, we can look at any capacity. It should give us the same answer. Let's look at all 3 capacities. Using units per second, remember, what is the definition of bottleneck? Bottleneck is the step with the lowest capacity. So among 1 by 50, 1 by 60, 1 by 30, 1 by 45, and 1 by 40, 1 by 60 is the smallest value. That's why worker 2 is the bottleneck. Now let's look at units per minute, if that would give the same answer or not. The capacity is 1.2, 1, 2, 1.33, and 1.5. Among these 5 values, 1 is the smallest value, so worker 2 is the bottleneck. Looking at units per hour, the capacity of the first worker is 72 units per hour. The capacity of the second worker is 60 units per hour. The capacity of the third worker is 120 units per hour. The capacity of the fourth worker is 80 units per hour. The capacity of the fifth worker is 90 units per hour. 60 is the smallest value. That's why worker 2 is the bottleneck. Thus, we have answered both questions. The first question asks what is the bottleneck. So we know worker 2 is the bottleneck. The second question asks what is the capacity of the assembly line, or same as saying what is the capacity of the process, or what is the process capacity, and express this in units per hour. The process capacity expressed as units per hour is the capacity of the slowest worker, or the capacity of the bottleneck, which in this case is 60 units per hour. Now if the question had asked what is the process capacity expressed as units per hour, we'd have reported this answer. If the question had asked what is the process capacity expressed as in the units per second, we'd have reported this answer. But the question asks what is the process capacity, express this in terms of units per hour. That's why we report 60 units per hour. We'll do the remaining problems in the next video.